In this video, I'm going to demonstrate how to create a confidence interval around a sample mean. And we're going to actually illustrate this using SPSS. So the variable that we're utilizing is the achieve variable right here. And so we have sample data from 16 individuals concerning their level of academic achievement. And I want to create a confidence interval around that particular variable. So you can think about confidence intervals as another way of estimating a population parameter. And when we're talking about a confidence interval around a sample mean, we're using the interval as an estimator of the population mean. So in other words, the sample mean is nothing more than a point estimate for a population mean, but an interval estimate provides a little bit more wiggle room when it comes to estimating the population mean for that particular variable. So let's create a confidence interval around the achieve variable. So what we're going to do is we're going to go to Analyze, go to Descriptive Statistics, and then go down to Explore. We'll click on that, and we'll move the achieve variable over to the dependent list. Where it says Statistics, we're going to click on that button, and you'll notice that by default we get confidence interval for mean set at 95%. So in other words, we're going to have a default confidence interval of a 95%. So the basic idea behind this too is that when it comes to confidence intervals, or when it comes to any estimate of a population parameter, you could think about that estimate as coming from a sampling distribution. And so with respect to our sample means, you could think about it as coming from a possible sampling distribution of means. And so the basic idea is that if we take repeated random samples of a given sample size from a population and compute all possible sample means, then those sample means would exhibit a distribution of its own. And when it comes to forming an interval estimate, what we're essentially doing is we're providing a range of possible values around our sample mean to serve as an estimator of some true population mean, so the true population mean for our variable. And so we don't necessarily know whether the true population mean actually falls within the interval, but if we form a 95% confidence interval, then there's a pretty good likelihood that whatever interval that we form based on our sample data, it may overlap with the true population mean. So that's the basic idea behind it. So let's go and run our analysis using SPSS. So now we're going to click on Continue and then on OK. And so now you can see that we have, using the Explore function, under descriptives, we have the sample mean, which is 10.375. And you can see also the 95% confidence interval. It gives you a lower bound of 8.7958 and an upper bound of 11.9542. So the basic idea is that this provides an interval estimate of the population mean. We have no guarantees that the true population mean, which we'll denote again as mu with a little subscript x, we have no guarantee that the interval actually contains the population mean. But if you go back to our sampling distribution concept, if we draw repeated random samples from a population and compute all possible sample means and all possible confidence intervals of 95%, then we would expect that 95% of the time that the interval that we compute would overlap with the true population mean. So just keep in mind that this does not guarantee that the population mean, the true population mean, which really is essentially an unknown, whether that falls between 8.7958 and 11.952. There's no guarantee of that. It's just we have a 95% probability that if we form a confidence interval using a random sample from the population, that we have a 95% chance that that confidence interval would overlap with the true population mean. So that's the basic idea behind it. So let's also look at another example. Let's try a 90% confidence interval. So I'm going to go to Descriptive Statistics, Explore, and we'll just form a 90% confidence interval around the sample mean. So we'll click on Continue and then on OK. And so now you can see the sample mean is going to be exactly the same. It's based on the same data as we had before, so that's it right there. And the 90% confidence interval ranges between 9.0761 and 11.6739. So you can see right here that the interval, the range of values is actually a bit smaller than it was before. And what that basically means is there's less of a likelihood that the interval estimate that we have right here would overlap with the true population mean. So when we form a confidence interval, such as a 90% confidence interval or 68% confidence interval, we have less confidence of overlapping the true population mean than if we form a wider confidence interval, such as a 95% or a 99% confidence interval. And to just further demonstrate that point, we'll go back and select Explore. And in this case, we'll ask for a 99% confidence interval. So I'm going to select 99%, click on Continue, and then on OK. And so now you can see, again, our sample mean is exactly the same. And you can see that the range between the lower bound and the upper bound has now increased. So now we have a greater likelihood that our 99% confidence interval overlaps with the true population mean. Once again, that does not guarantee that this particular interval, that the population mean falls exactly between 8.197 and 12.5583. Only that there's a 99% chance that if we form confidence intervals using a 99% confidence interval approach, that 99% of those confidence intervals would exhibit an overlap with the true population mean.